In this lesson, we're going to work with all of the arithmetic operations that we've learned, all four polynomial operations. We're just going to build some fluency. So we're going to talk a little bit about standard form, factored form, and maybe some vertex form in there. We've already talked about really polynomials and the difference between standard form, change that into factored form, and even vertex form, which I actually haven't talked to you about yet, but we will get there. Okay, these are all equivalent polynomials, okay? So, I'm sorry, that's really funny. And here we go. We've got standard form, factored form, and vertex form. And these are equivalent to each other. Okay, you could multiply this out and you would see this. You could multiply this out and you would see this. All right, as you can tell, we skipped exercises 1 through 16, but don't fret. Exercises 1 through 15 were sort of a fun little game that may have worked in a rather large class where we were working 15 different polynomials and trading them and checking answers. And then, gosh, exercises 16, we're using those polynomial cards to sort of put in a graphic organizer, but not to fret. You guys are going to get plenty of practice not doing those exercises. So right now we're going to talk about combining polynomial operations. You're going to use your order of operations, which I hope you guys all remember. First we do parentheses, which really is any grouping. Okay, not just parentheses, but brackets and fraction bars. Exponents, and then multiplication, division, left to right, and addition, subtraction, left to right. So that's how we determine what operation to perform first. So let's get the first one on here. Okay, you already see this problem on your sheet. Let's go ahead and work it. So we're applying operations in the appropriate order. First, you look, we have parentheses. Okay, inside this parenthesis, there's nothing I can simplify. Inside this parenthesis, there's nothing I can simplify. This is also considered a grouping, so it's in the parenthesis category. So we have to finish the top and the bottom before we do anything else. So let's go ahead and work on that top and simplify it a little bit. I'm going to remove, which I can't. I'm going to ignore the parentheses. And because this is a plus, I can just ignore these parentheses also and start gathering like terms. So x squared plus x squared is 2x squared. 5x plus 6x is 11x. 20 minus 6 is 14 over x plus 2. So there's nothing I can do to simplify the numerator and the denominator any further, so I'm going to go ahead and multiply this. Divide this. And it's magically appearing on the next screen. So x goes into 2x squared. 2x times x is 2x squared. 2x times 2 is 4x. Subtract 11 minus 4, 7x. Carry the next term down. And we get 7 times x is 7x. 7 times 2 is 14. And we have a remainder of 0. So this is our answer. Sorry, that was number 17. So let's look at number 18. X squared minus 4 I'm going to pause it so I can write this. All right, PEMDAS tells us parentheses, exponents, multiplication, division, addition, subtraction. So let's look inside of each of our parentheses. I've got this set of parentheses here. I can do something inside there. Actually, no, I can't. I'm multiplying, so I can't do anything inside there. I can't do anything inside there. I can't do anything inside there. But my next thing is exponent. There's no exponents I can do anything to, but I can multiply these two terms and then subtract. So I'm going to use the FOIL method, which is distribution. I could use the tabular method also, but I'd rather not today. I have x cubed, which is first times first, 3x squared, distribute that, and then minus 4x minus 12. Let's simplify. I'm still in these parentheses, minus all this other stuff. Let's simplify that. X cubed. Did I mess up? Nope. I can't simplify anything in there. Silly me. Let's erase that. And actually, let's erase that. It's important to remember, if I look at this negative, if I take down this parenthesis, I need to distribute that negative to each term. So it's going to be minus an x squared minus a 2x plus 5. Now I can collect like terms. X cubed, I have a 3x squared minus x squared minus 4x minus 2x minus 12 plus 5. Check the answer key, and we are correct. Yay! Okay, number 19, what you see on your classwork paper. You don't have to watch me do this one. I'd like you to practice this one on your own and just check your answer. So go ahead and push pause and come back when you are done. All right, with number 19, I found a shortcut, so I used it. So I wanted to explain that to you. I know we need to do our parentheses and our exponents first. Can't do anything inside, but I can expand the polynomial and multiply. So I've got the top of the fraction, the bottom, numerator and denominator. Let's multiply two of these out. Okay, distribute, and I have, let's come down here, x squared minus 6x plus 9 is two of these multiplied together times x plus 3. And then I recognize that this polynomial and this polynomial are equal, which means I can cancel them out, and I'm done way quicker than continuing to multiply and then doing some long division, because long division takes a long time. Let's look at number 20. Okay, you see number 20 on your sheet also, so I'm going to do this one again paused, so go ahead and push pause and then check your answer. All right, first I multiplied these two polynomials. Then I distributed this negative just in this parentheses of polynomials. And then I rewrote everything. Okay, I collected like terms. So first I got the x squareds, then I got the x's, then the constants. Then I realized I left one out, so I added it back there. But it's never good to put your highest order at the end. It should always be at the beginning, so I rewrote it. All right, exercise 21. What would be the first and last terms of the polynomial if it was rewritten in standard form? Answer these quickly without performing, sorry, I had to sneeze, without performing all of the indicated operations. So this really is just grabbing the biggest orders and the smallest orders and trying to be fast and accurate. Okay, these are my two highest orders. This is a plus, so I don't have to change any signs. I have a positive 2x cubed and a negative 6x cubed. That leaves me a negative 4x cubed. My constants are going to be at the end. I have a positive 7, a negative 9, so that's giving me a negative 2. Okay, this is a good practice for when we start to graph higher order things. It's how the graph is going to act is all given by the first and the last terms. Okay, here, first term, it looks like I've got 3x's, which is going to be something x cubed. If I look at all my terms, it looks like I might have a 2x cubed. Okay, my last term, I've got all my constants, which will get multiplied. So negative 9 times a negative 1 would be a positive 9. I don't know why that's in blue now, sorry. Okay, let's see, a little more complicated. Looks like right here I'll have a 6x squared, and over here I'll have a 2x cubed. So I'm looking just for my higher order, so that's not going to be my first term. Here I have, it's going to be a negative x multiplied to a positive 2x squared. So that's going to give me a negative 2x cubed. Excuse me. And then my last term, let's see, constants here. I'm going to erase this stuff. Oops. Getting a little messy. Constants here, I'll have a negative 15. Constants here, I'll have, looks like a negative 3, because this negative needs to get distributed. So 1 and positive 3 is negative 3. That's going to give me a negative 18. All right, this last one. Looks like on this term, I'll have an x squared. And on this term, I'll have a 3x squared. That's going to give me a 2x squared. My last term, here a negative 5, here a positive 16. That will give me a positive, nope, double check. Oh, this negative right there. There we go, a negative 21. All right, so how did we determine our answers quickly? I knew the first term was going to be the one with the highest order, the highest degree, so that's what I focused on, and then the last term is going to be constants. Unless the constant turns out to be 0, then you have to get the next smallest order, the next smallest degree. Did any of the solutions surprise you? Not really. I guess you can answer that for yourself. All right. Exercise 22. What would the first and last terms be of the polynomial if it was rewritten in standard form? I'm going to push pause and work through these if you want to work through them yourself. All right, there you go. If any are surprising to you, we can chat about it next class period I see you. But go ahead and look through the answers and make sure they make sense. All right. How is polynomial arithmetic similar to integer arithmetic? I mean, we use PEMDAS with all of it, right? So they're very similar. We do everything in the right order, or you won't get the right answer. How can you quickly determine the first and last terms of a polynomial without performing all the operations needed to rewrite it in standard form? I analyze all of the high degree terms first, then the constants. Because if we're writing it in standard form, constants, then yeah, your highest degrees are going to be at the beginning and your constant will be at the end. We'll see if we do an entry ticket tomorrow, but you guys have been doing fantastic.